Hi and welcome to Challenge 21, round to n decimal places. This is the very first challenge in the second series of challenges. So far we have had two series. We had challenges 1 to 10 in which the primary focus was strings. Then we had challenges 11 to 20. The primary focus of which was arrays. This is going to be the third series in which we have 10 challenges again, and the primary focus is number operations. So we are just going to deal with numbers throughout these challenges. And the way we solve these is going to be the same as the previous 20 challenges. We're going to use for JavaScript, Python, Golang, and Rust. We're going to use a mixture of built-in methods, and if we don't have a built-in method, we're going to do that manually, that specific part of the logic. But when it comes to TypeScript, that's going to be the language in which we're going to try to go as manual as possible, just to avoid using built-in methods, so we can just think about this and really understand what challenges and how to solve this. So what is this challenge? The challenge number is 21. And our job is to round a specific number by a specific number of decimal places. So the number that we accept is going to be floating type. That means it has decimal points. And if I have 2 for this number, so that means 3.14159 becomes 3.14. The same thing goes for the other two inputs and outputs as well. And if you take a look at the third one, where we have 9.5, where we don't specify like 1 or 2 or 3 decimal places, we just say 0, then that means we are going to round this number. If it is 0.5 or above, that's going to be rounded up. If it is going to be less than 0.5, that's going to be rounded down. So 9.5, that's going to be rounded up to 10. The first language, much like the previous challenges, is going to be JavaScript. And for this specific challenge, I'm going to give you 2 different solutions. You're very welcome to explore this challenge further and find other solutions, but I'm just going to strict myself to these 2. So we have a function that is going to say round to decimal, and this is going to be v1. We are going to pass in the actual number and then the decimal places. Now, instead of writing decimal places, I'm just going to write decimal. For the first one, for the first solution, I'm going to use the toFixed method, which actually is going to strict a number by a specific number of places, a number of decimal places, I would say. So we have this method available on numbers. You could use it on numbers, but the thing with this is that toFixed actually returns a string. So later on, we need to convert it in number just to make sure that this function returns a number. And places is going to be an argument that we pass to toFixed. So if a number has 5 decimal places, like the first input, and places is 2, it's going to get rid of the 3 last decimal places. It's just going to keep the first 2 decimal places. And then we are going to store this inside of a variable, which is going to be fixed string. That's very important. This is a string. Now you could use the number method in order to convert this to a number as well. This method only works on numbers that are surrounded by quotes. So the result has to be a number. And after that, I'm just going to copy paste our test cases. So this is the very first way to solve this. And now it's time to talk about the second solution. And the second solution, in order for me to actually explain that, I'm going to create a comment here. So the first number is 3.14159, and the decimal places is 2. What does this actually mean? It means we have this number 3, and then this point, and then this 1, and then this 4. So for the second solution, the way that I'm going to go about this is, however many decimal places I have, I am going to multiply this number by those many decimal places raised has power to the number 10. So what do I mean by that? I actually explain that in reverse. So I have, let me just put the 2 back. I have this number 10. So I'm going to say there are 2 decimal places, right? So that's going to be 10 raised to the power of 2. What do we get? If I do this, we get 100. Then I'm going to multiply this 100 by number. What do I get after that? I get 314, then I get 0.159. Why did I do this? Because if we have any number after the required decimal places that is not 1, that is 5 or above, we are going to round this 4. What do I mean by this? So if you say you have this 2.718, right? If I come right here and let's say we want to have only 2 decimal points. Now this is no longer 2.178. What is going to be the output? The output is not going to be 2.71 because the number that comes after 1, that's 8. That's above 0.5. So we round 1 to 2. That's the rounding logic that goes behind this. So it's very important to find out what is the immediate number right at the border where we specify how many decimal places we want. That's very important. So I'm just going to go back here. Now, I want to find out that number. That's why I'm going to multiply this by 100. So 100 comes from 10 raised to the power 2. This 2 comes from the decimal places that user wants to specify. So I end up with this number, 314.159. So now I have found what is the border number, like this number right at the next part of this second decimal place. So the first decimal place is 1, the second one is 4, and then I need to take a look at the third one as well, or the next number, just to know if I should round this 4 up or round it down or just leave it as it is. Imagine if this 3.14, it was 14559. That would have been 3.15 because we would have rounded 4 up. So now that I have found this number, what am I going to do with this? I need to find out if I have to round this up or if I have to round this down. Now in JavaScript Solution, that's easy. We can just use the round method, which is available on the math.round. This is going to automatically round a number up or it's going to round it down. So if I pass in 314.159, what is this going to generate? Well, this is just going to give me 314, nothing else. So if this was 314.559, this would have given me 315. See, the result is different. Now, because it's 1 and 1 is less than 0.5, it's going to round it down. You know, like at the half point, you round it up. Beneath the half point, you round it down. So rounding down means the same number. So I got this 314, but 314 is not my output. It's 3.14. Now remember, I multiplied this number by 100. Now if I just select this number and divide it by 100, what do I get? I get 3, let me add some spaces. So I get 314 divided by 100. Now, it's the same 100 that I used here. What do I get? I get 3.14. And 3.14 is the output. It's like going a longer way to achieve the same result. And now what we need to do is just write this in the form of like code. That's what we need to do. So I'm going to zoom this out. The first thing we need to do is we need to have a function that does this calculation. And we're going to call it round to decimal v2. This function, we know that it accepts number and it accepts places as well. And now we need to first find out this 100. Now it was 100 because it was 10 raised to the power of 2. Now we can see, okay, we are always going to have 10, but this 2, this is variable, this is dynamic. It comes from the places. So I can say places is going to be the exponent of 10. And how do I write that? I am going to create a variable. I'm going to call it multiplier. And now what I'm going to say, I'm going to grab the math.pow method, which is going to raise something to the power of something. So what do you want as your base? That's going to be 10. But what do you want as your exponent or as that power to this base? That's going to be places. So the base is always going to be 10. It's going to be a multiplication of 10. So if places is like, let's say 5, 10 is going to be raised to the power of 5. So it's like, it's going to be 10 multiplied by 10, multiplied by 10, multiplied by 10, and multiplied by 10. Cool. So this is going to be the multiplier. And then what did we do? So that was step 1. We got this 100. Then we need to get this 100 and multiply it by num, so we get this thing. So that one, I could just call it shifted, because we're shifting the decimal point. Shifted. And what did we do? We grabbed our multiplier and we multiplied that by the number. So I'm following the same thing, but I'm converting it into dynamic code that works with any number. Then what did I do? Well, I passed this, whatever this produced, I stored it inside of shifted, and then I passed it to math.round just to round it up or round it down. It's as the method says, it's going to round it to the nearest integer. This is what I was looking for. Nearest integer. So nearest integer for 1 is going to be, it's going to be 0, right? But nearest integer to 5 or 6, that's the next integer that comes. Cool. So here I'm going to pass and shift it. Now I need to store this somewhere, right? And this is going to be our rounded number. So far we did the power, we did the multiplication, we found out this number, we passed it to round, and round has given us 3.14. So this rounded number at this stage, this is 3.14. There are no decimal places, but keep in mind, we want to restrict decimal places. We don't want to get rid of them entirely. So now we need to bring decimal places again. And how did we bring them? We are going to say return. We grabbed the number that we ended up with. So here, when I selected this number, this is not the number, this is not the initial number. The initial number has been changed a couple of times. Now this is this rounded. And we select this rounded. Well, I should have said here as well, like rounded. We select the rounded divided by 100, which is 314 divided by 100, and we get 3.14. So I select the rounded, I divide it by the, so should I divide it by 100, 200? I'm not sure. Like 1,000, 10,000, 100,000, 1 million. It's not going to be 200, but it's going to be like 10 to the power of something. But we specified that using the multiplier because we want the solution to work for any number, and that's it. Now you know how this actually works. You have like a second framework of like really understanding this. And I'm going to select these console logs, put them right here. We could select this V1 and just convert it to V2. Let's come right here. We need to first navigate to this directory, and then I'm going to say node A tab, hit enter. There we go. And it is working expectedly, right? So we had 3 our test cases. Let me just bring this down. We had 3.14159. Just you want 2 decimal places, so that's 3.14. Then you have 2.718 and then 10. Now for the round to decimal v2, I am going to change the decimal places from 3 to 2. This means now we should have 2.72. But that's going to be for the second version of the solution, not the first one. So for the first one, I didn't change the decimal places. That's why it's the same. But for the second one, take a look at this. We have 2.72 because you need to round it up. When you round this 8 to the nearest integer, it's the next one. So it adds 1 to this 1 right here. So it's no longer 2.71, it's 2.72. Cool. So now that you have understood this solution, let me just clear this up. This is going to be the solution, the way that we are going to solve for other languages as well, aside from TypeScript. We're going to use this as the second way of going about the challenges solution. But the first way of challenges solution, that's going to be more built-in method, like specific and short and concise. So now that we have implemented the JavaScript version, let's jump into TypeScript. And the TypeScript solution is very simple. But the steps that we want to solve this is going to be almost similar to the way we went with JavaScript, the second version. So I should put that here as well. So for the second version, what did we do? Now keep in mind, we want to go as manual as possible. We don't want to use any built-in methods. So the general idea is that we created 3 variables. One was the multiplier, the other one was the shifted, the other one was the rounded. Even though in 2 of these variables we used built-in methods, we used math.pow and we use math.round. But in TypeScript, we are going to create these variables, but we need to not use these built-in methods. And we should come up with some other way of doing this. So the first thing that I'm going to do with TypeScript is still going to be this multiplier, but it's not going to come from math.pow. So how do we go about this solution? Well, the first thing we must do is create the function. That's going to be round to decimal, and that's it. There is just one solution for TypeScript. We have a number that is going to have a type of number. We're going to have another parameter, which is places. The type of this is number as well. What this function returns is going to be another number. This is very good for type safety. So the first thing is we create the multiplier. So we know that the multiplier is 10 raised to the power of something. That thing is places. Now it's a little bit difficult to raise a number to the power of another number manually, but if it is raised to the power, you can just unpack that. What do I mean by that? So if I say 10 raised to the power of 2, if I unpack this, this basically means 10 multiplied by 10. Cool. If it is raised to the power of 3, this means 10 multiplied by 10 multiplied by 10. So something raised to the power of something basically means the base is going to be multiplied by itself by those many times. And what are those many times? That's the power. So if the power is 5, base is going to be multiplied by itself 5 times. So now that we have established that these are the same thing, we can go like this. So I'm going to create a variable multiplier. I'm going to initialize it to a value of 1 because we need to have this value. Then we are going to say, depending on how many places we have, we could have 10 multiplied by itself by those many places. But we need to do this in a manner that is repetitive. So for this reason, I'm going to use a for loop. So let me just click here. That's going to be for loop. We're going to have for let I starts at 0. That's the for loop convention. It's going to start at 0, where I, it's going to go as long as we have places. So if places is 2, I is going to iterate 2 times. That means I is going to be 0 in the first iteration. In the second one, I is going to be 1. But I is not going to go 3 iterations because we just have 2 places. That's why we say I is going to go and it's going to iterate 1 less than the number of places because I starts from 0. Now you could say I equal to places, but then here you need to start I1. But this looks very weird. And that's not the convention. The convention is just like this. I starts from 0. It comes from arrays, if you're asking that, because for loops are just working for arrays, working with arrays mainly, and arrays have an index that starts at 0. That's why the loop agent, or I, which is short for item of the array, that item starts at 0 because the first item inside of an array has an index of 0. So I get that convention where the convention is. So if I just deviate from the convention, it just looks weird to me. It doesn't mean it doesn't work. It is just something that I have to, okay, why did I do this? Okay, so it's like something that has already been approved. I'm just going to go with that. That doesn't mean I don't break rules. So we're going to have a multiplier be repeated as many times as we have places. So that is something that we have established. So if we want 2 decimal places, that means we need to have 10 multiplied by itself 2 times. So 10 multiplied by 10. That means our loop has to run 2 times. And what does that mean? So, and this is the reason that I've specified multiplier as 1. If I specify it as 0, every time I multiply 0 with 10, it's still going to be 0 because 0 multiplied by everything makes that thing 0. I'm going to select the multiplier and I'm going to multiply it by 10. Now, how does this actually work? In the first iteration, I is 0. Now keep in mind, we're not using the value of I inside of this loop. The reason that we need this loop is because we want to repeat a piece of code a number of times, a dynamic number of times, but we are not sure how many times we want to repeat that because places could be dynamic. It could be 2, it is dynamic. It could be 2, 3, 5, 10, 12, whatever. So that's why we use loop. Now loop is just here. Now the idea behind loop here is just to repeat what's inside of it as many times as we have places. So we have places 2, that means loop is going to repeat this 2 times. The first time it's going to multiplier by 10. So multiplier is 1. 1 times 10, that's 10, right? And then I'm going to store that 10 as the new value of this multiplier. Now, after the first iteration, multiplier is no longer 1, it's 10. And then I go to the next iteration. When I go to the next iteration, what happens there? I multiply these 2 again. So multiplier is already 10. 10 times 10, that's 100. So the last value of multiplier is 100. It's exactly the same as math.pow. So it goes like this. You have multiplier. This is going to be 1 multiplied by 10. That's the first iteration. So I could say first iteration. And second iteration is 10 multiplied by 10. That's the second iteration. Second. Why? Because we have already changed the value of multiplier by 10. Basically, how many times should we multiply 10 by itself? If places is 2, we multiply 10 by itself 2 times. And we use this for loop just to achieve that logic. And that's it. So now the latest value of this multiplier, if you do a console log right here, that is 100. If places is 2. If places is 5, that is going to be 100,000. And it's multiplying and it is getting bigger and bigger. That's why I call this multiplier. Now that I've found out what my multiplier is, what do? I select this multiplier 100 and I multiply it by my number, with my number. So I have this multiplier. I multiply this to my number Or how did I go about this? I said, yeah, multiplier times number. Then I get something that I called shifted, right? So const shifted. This basically gives me, if number was 3.14, this is going to give me 314.159. At this point, this is what I got. So at this point, right here, this is going to be the shifted value. Let me just put it there. And we need to keep in mind that multiplier is 100 here, right? Why is it creating these comments weird? Now that I have this shifted, I need to round it up, right? How do I round this up? That's the more difficult part of this solution. Well, to round this up, I need to find out what the fractional part of this is. Now keep in mind, shifted contains 314.159. As I explained before, we are interested at the number that comes right after the decimal places that we want, that interests us in rounding up or rounding down. What do I mean by that? So we know that the actual number, let me grab these right here, put them right here. Very good. And I'm going to get rid of this, save this. So if I were to say this is for the second test for this one, so let me add some spaces here and I need to zoom this in. So for the second test, we have 2.71828. I want to round it by 2 decimal places. So when I want to round it by 2 decimal places, that means 2.71. But that doesn't mean 2.71. That's not the result. The result is we need to take a look at what comes. I need to zoom this even further. Let me just get my cursor and zoom it right here. So why doesn't that work? The reason that doesn't work is as following. So we have this number of places is 2, so that means 7 and 1. We need to take a look at what is at the edge, or what is the next number after the second decimal point. If that number is 0.5, if it is 5 or higher, that means we round this 1 up. That means 1 up. If you want it up, that's 2, right? You add 1 to it. But if this is less than 5, we don't do anything, meaning we round it down. We keep it as it is, much like here. So 2 decimal places means 1 and 4. But the next number after the second decimal point is 1. And 1 is clearly less than 5. So we don't do anything to this 4. And that means the result is going to be 3.14. But here, the result is not 2.71. It's 2.72. Because 8 makes this 1 round up, not round down. Because 8 is greater than 5. That's how math works. So if it is greater than 5, you round this thing up. So that's very important for us. That's why it's very important for us to take a look at the number that comes right after the required or the desired number of decimal places, aka the desired places. So if desired places is 2, you take a look at the third number. If desired places was 4, you would have taken a look at which number? At the next one, which is the 5th one. So this is how we go about the solution. That's why not only it's important for us to get 2.71, it's also important for us to get this 8. Because 8 specifies if it is going to stay 2.71 or 2.72. And this is very important because this 9.5 is actually going to be rounded up. We're going to get number 10. So you can clearly see 9.5 is different than 10. So that's why rounding is very, very important. Let me just zoom this out again, and there we go. So this is the TypeScript solution that we're in now. Now I want to round this, but I can't use math.round. The first thing I'm going to do is I'm going to take a look at this entire decimal places. What even I have here? But I can take a look at this. I said we're talking about this first number, so I'm going to come back here, right? We shifted this. So now we no longer have 3.14159. We have 314, which is our number, the whole integer, plus its decimal places that we require. So take a look at this 3.14. What do you see? You see three numbers. Two of them are the required decimal places that we want. One of them is that bigger part, that whole part of that decimal number, right? So this is going to be 3.14. But for us to decide if this is 3.14 or 3.15, we need to take a look at the immediate next number, and that is 1. And how do I take a look at that? This is dynamic. It could be whatever. It could be 1, 2, 3, 4, 5, 6, 7, 8, 9. How do I take a look at that? The way that I'm going to take a look at that is going to be, first I'm going to grab all of the decimal places that are remaining inside of this number. That's the first thing that I'm going to do. How do I select that? Well, we need to manually extract that, and the operator that I'm going to use is going to be the modulo operator. And modulo operator is very, very interesting in this scenario because I'm going to just show it to you. So first off, let me just write this fractal part. The reason that it is very important is if you use modulo operator and you apply it on 1, it's going to give you the decimal places within that number. So the modulo operation, what it does is it gives us the remainder after division. So if I select this shifted, use the modulo operator, and if I say, okay, shifted modulo operator 1. Now keep in mind, this is not division. I'm not saying shifted divided by 1, because if you divide anything by 1, it's that thing. It doesn't change. I am saying shifted modulo 1. That's the correct terminology. If it is a number that has decimal points and you say modulo 1, it's going to give you the decimal places. That's the cool part about this. So 3.14159 is shifted. We say modulo 1. What is going to be the result? The result is 0.159. And now that I have this 0.159, I can take a look at this. I can take a look at these decimal places and not disturb the actual shifted number. So I want to see if I should round 4 up or round it down. Now that I have found this, I am going to subtract this. So I'm going to say const. We have a fractional part. We need to have an integer part as well. So this is going to be integer part. And what do we do here? Well, we have this shifted. We subtract it by the fractional part. What this gives us? This is going to be 3.14.159 minus 0.159. What do we get? We get 3.14. And now we know if I divide this I think I said that incorrectly. So we have 314.159 minus 0.159, we get 314. So if I divide this 314 by my multiplier, which I know is 100, I'm going to get 3.14, and that's the solution, right? But the problem is that what if the next number is 5 or above? And that's no longer going to be 3.14, that's going to be 3.15. So that rounding is where we actually end up with the headache. So here is where we need to create this variable. Remember, we have not created this rounded. We need to create that. That's going to be let rounded. The type of this is going to be number, but I'm not going to give it any values. So how do we decide this? We say if fractional part is we know that if the fractional part is 0.5, if it is 5 or above, we round it up. So if it is 0.5 or above, we round it up. That means rounded is going to be the integer part. Take a look at this. Now, I'm not dividing this by multiplier just yet. Keep that in mind. That's going to be our last step. So I'm going to say rounded is going to be the integer part plus 1. And what is this going to give me? Let me just write it here. So rounded is going to be 314 plus 1. What do I get? I get 315, which is rounded. This is if 0.159 is greater than 0.5. Is 0.159 greater than 0.5? No, it's not. It's almost like 1/3 of it. Almost. It's not. So we don't go inside of here. We go to the else if. We go to the next condition. Else if we need to provide the condition, the something that is going to be evaluated at Boolean true or false. So here is if fractional part is less than or equal to negative 0.5. Then if it is this, then we reduce 1 from it. So rounded is going to be integer part. And that's, now this is for negative numbers. Since we don't have any negative numbers, I'm still going to put this here. You could add a negative number and this would work, but this is going to be for negative numbers and we're going to reduce it by 1. But if we round up or round down, is always the same number. So 314.5, that's going to be rounded up. You're going to get 315. But 314.1, it's always going to be 314. So if you round any number down, you don't change the number. But if you round it up, you add 1 to it. That's the important part. But I wanted to add that so you pay attention to in case you have negative numbers. And then if we don't round it up or round it down, right? So if it is not, so if the fractional part is not this, and it is clearly not this 0.5, this minus 0.5, rounded is going to be the integer part itself. In our current scenario, we know that this doesn't apply, so I'm going to get rid of that. We have 3.14, and the fractional part is not greater than 0.5. So we don't go inside of this if statement. This is not going to be implemented. We go to the else if. We see that fractional part is not less than 0.5, minus 0.5. It is 0.159. This is a positive number. So else if is not going to be implemented as well. It's not going to be evaluated to true. Therefore, we go to the else. And else says rounded is going to be the same integer part. And what does this mean? It means rounded is 3.4, 314, and integer part is 314. So this is the value of rounded. Now, what do we do with this rounded? The last thing is just divide it by the multiplier to end up with the decimal points. Remember, multiplier remembers how many decimal places user wants. So I'm going to select rounded and I'm going to divide it by those many decimal places. So if you have a whole number like 314, you want to add 2 decimal places. You know that mathematically you have to divide it by 100. If you wanted to add 1 decimal place, you would have divided that by 10. If you want to add 3 decimal places to 314, you divide it by 1000. And there we go. That's it. So I'm going to keep this second part, this part 2.71828 as 2, so we can see how this actually works. So this is how these methods actually work. So you can see here you just have math.round and it works magically, but this is everything that goes into it, right? So I want to give you these ranges as well. The first one is going to be 0.5 or above. For the second one, I want to give you the range. That's going to be negative 0.5 to that's going to be negative 0.5 to 0.05, but it doesn't include 0.05, right? So this is going to be the range. How do I specify this? I could add this. And the other one doesn't have any ranges. So because here we said, okay, start from here and go up until there. Cool. Now we need to first compile this. That's going to be TSC B-tab. Round to n decimal places, hit enter, and then we're going to select B-tab. Now, when you're running this, you need to make sure that it is B, so it's the TypeScript solution, and the extension is JS. Hit enter, and there we go. So we got 314 expected, and now take a look at this. It's not 2.71. We rounded it up. It's 2.72. And then we get 10 magically as well. But if I were to bring this down, just zoom this out a little bit. And if I say, okay, this is 3 decimal places, get rid of these spaces, save this, click here, TSC, and then node, and then there we go. We got 3.14, and then 2.718, as well as 10. Cool stuff, right? This was TypeScript, as usual, longer, more explanations are required here. For Python, we're going to have 2 solutions, so I could just keep the JavaScript version open. Let's go to the Python version. Python, the first one is going to be as short as the first solution that we had for JavaScript. So it's going to be def round to decimal v1. What is this going to accept? This is going to accept number as well as places. Now, here we can just use the round method. Round method is going to select a number and it is going to round it by however many places you specify, and then we return that. And that's it. And the next thing is to just go ahead and copy paste the print statements. These are lowercase b's, better. This is the first solution. For the second solution, we're going to go almost the way that we went with the second solution of JavaScript. That's why I took more time to explain how that works, because these languages are going to be going the same way. I don't want to reinvent the wheel every time I grab and I add a new solution. I just want to make sure that there is some consistency to understanding, okay, this is how you can solve this. Okay, this is one of the ways you can solve this. All right, so how do you go about this? The first thing was we need to find multiplier. So I'm going to say multiplier is going to be 10, but this 10 is going to be raised to the power whatever the places is. So if we have 2 places, we're going to raise it to the power of 2. That's going to be 100. And you already know this, so we really talked a lot about this. And if you're wondering, this double asterisk, this is called the exponentiation operator. And yes, we do have this in JavaScript and in TypeScript as well. And yes, you could remove the loop entirely and use this exponentiation operator instead of that. And that would work perfectly fine. You would just add constant, that's it. But the reason that I didn't do that was just to show you how that would work manually. That was just a teaching point, not a technical limitation. But of course, if you choose that, you could go about that as well. My aim, as I have stated that several times, is to just practice programming, like really stimulate the brain when it comes to like finding different ways and like really thinking about, okay, how does this actually work? Can I do this a different way? As a challenge for you, you could come up with a way not to use even the modulo operator, because you could argue, okay, that is a high-level operator. Like we have simple arithmetic operators like plus, minus, subtraction, and multiplication. but you could say, okay, modulo doesn't fit in that. So it could be, you could classify it as a higher level operator, and that could be a very good challenge for you. But please do not use AI to think for you. You could very well do this. You could use subtraction or truncation logic to work with in order to replace the modulo operator. Okay, let's move on from this discussion. So we have shifted. For shifted, we know that we select the multiplier, we multiply it by num. This is going to give us the number that we have. So the whole part of this floating point number is going to contain our number and our desired decimal places. But then in order to take a look at if we need to round the last number up or down, we need to round this. So that's going to be rounded. This is going to be equal to round. So we have this round method in Python as well, to which we pass shifted. It's going to take a look at whether it should round it up or down. We don't have to worry about it. So we have this rounded. Finally, we grab it and we divide it by 100 or 1000 or 10,000. No, we divide it by multiplier. And that's it. So let me just select this, put it right here. For this second version of the solution, I could change this decimal places from 3 to 2. This is going to be 2 as well. Now let's run this. This is going to be Python C-tab, enter. So we got 3.14, 2.718, 10, 3.14, 2.72, and 10. Cool. This is the Python solution. And now the next one is going to be the Go version of the solution. For that, I could keep the JavaScript one open. That's okay. Now, for Go, since we already have like some kind of an error, if there are, we already show an error. If there is nothing, so every Go file has to be like a valid Go program. And if you want a valid Go program, you need to add this, the main package. Cool. How do we go about this? Well, we're going to have two different ways of solution for this. The first one is going to be a little bit more complicated from the second one. And the reason for that is because the number of places or the number of decimal places is dynamic. It could be 2, it could be 3, it could be 4. And that's the more dynamic it is when it comes to especially the static languages, the more difficult it is to implement. So how do you go about this? Well, first off, we need to create our function. That's going to be round to decimal. We could say this is v1. What is this going to accept? It's going to accept a number. Now, number is going to be a floating point number. Therefore, I'm going to type annotate it as float 32. Places, this is always going to be an integer. There we go. But what we produce is we could say, okay, I want to produce floating point numbers as well. So if it is 10, it's going to be 10.0. That's okay. Now, how do you go about this? Well, the first thing is we need to dynamically specify how many places user wants to remove. Well, basically, when we say places, that's the number of places that user wants to keep, aka get rid of the other ones. So we have a method in Go. This is available on the FMT library, and that's called sprint if. So what this method actually does is it's going to build a string by inserting values into a template. And as I am creating this, I'm going to explain why do we go about this. So the first thing that I want to do is I want to find out dynamically how many places should I keep within num and how many places I should remove from num. Now, I'm doing the conversion to string because I want to make sure, okay, this looks like the JavaScript version of the solution, and it is easier if we go like this. So we're going to pass in places here, and places is not even the first argument of this. The first argument is something that's called a format specifier. format specifier has two parts. One part is on the left side of this dot. The second part is on the right hand side of this part. The one on the right hand side is easy. It's consisting of a percentage sign, D, which is going to be a placeholder for places. So if places is 2, D is going to be 2, and then F, just to specify this is a floating point number. On the left hand side of this, we have this percentage sign, which is going to say, okay, we're going to put literally this percentage inside of this string. And then we're going to escape this percentage sign by another percentage sign as well. So this is the format specifier. The first percentage sign escapes the second one. The second one specifies the start of the formatted string. Formatted string is of type floating point number. Now, it's not of type floating point number, it's of type string, but it is used for a floating point number. Then I could use short variable declaration to store this inside a format. Now, we did this because we needed to create a dynamic format string because places is variable. We cannot hardcode this. It's variable, that's why we created that. Now, what I'm going to do is, next is I am going to actually round the number. And for that, we could use the same method. That's going to be sprintf. And to this sprintf, I'm going to pass in the format. There we go. And I'm going to pass in the number. And what is this going to do is it's going to limit this number by these many, whatever the number of places it is. So if, let me just show it to you like this. So if we have this sprint, I'm not going to pass in the method, or should I pass the method? I could pass the method so you really see how this works. So format is going to be this. It's going to be a string that is percentage sign 0.2. If places is 2, that's going to be percentage sign 0.2 and then F. F stands for floating point number in this specific scenario. Number is 3.14159. This means limit 3.14159 to 2 decimal places and then round it up or down depending on the criteria. So if it is 1, you can see if we if we limit this by 2 decimal places, we have already talked about this. This 1 means round it down. That means do nothing. That means the result is going to be 3.14. And then we store that inside of another variable. Now, this is still a string, so I could just call it formatted. That was the format specifier. This is the format. I could say format specifier. Let's copy that. There we go. This is our number. And now this is the formatted string. You could say formatted string. And finally, what do? We need to convert this formatted string into a number because that's the return type of this function as well. So we have this strconv string conversion library, which I just imported. On there, we have this parse float to which I'm going to pass formatted string, and I'm going to pass in how do I want this to be converted into a number. I want this to be a floating point number with type 64. Now let's store this inside of results using short variable declaration. Now what this returns is also something else. That is an error. I'm going to pass in an underscore because I'm not really interested in the error and I want to ignore that since this is always going to be valid for us. We just enter numbers. And finally, we want to return a result. Return is typo, result. There we go. That's it. That's the solution to this challenge. Now, the next thing for us is actually call the main function, but I'm going to do that right after we are done with the second version of the solution as well. So this is going to be round to decimal v2. This is the simpler one of the two. We are going to select, I could select all of this, put it right here, add another curly brace. Now let's jump there. So what do I want to do here? The first thing is I want to find out my multiplier, and that is going to be, inside of Go, we also have the math module, which I just imported, or library, I would say. And on there we have the POW, which is the same thing as we had inside of JavaScript. So the base is going to be 10, but the places, that's going to be what we are going to raise this up to. But POW accepts float 60 point type. So I'm going to say float 64. I'm going to pass in places. So this is the multiplier. Next up, we need to actually make sure we grab our multiplier and we multiply it by number. And we store it inside of a variable, which is called shifted. I have already talked extensively about this. So I'm not going to dive into the details. We know we have this multiplier, multiplied by num. This is going to give us 314.159. Then we round this up. And this rounding is going to be math.round. You can see it's almost identical to the JavaScript version or to the Python version. We pass in here shifted. And what do we do next? Well, we select rounded and we divide it by a multiplier. And finally, if you want to run this, you need to have your main function. There we go. Save this. We're going to jump into the terminal. I'm going to say go run d-tab, enter, and there we go. What do we get? We get 3.14, 2.718, 10, and the same thing right here. For the second solution, we could limit the decimal places to 2. That makes it interesting. I'm going to do that. Oh, I have already done that for JavaScript. Cool. So now let's clear this up. Let's run this again. It works fine. So we have 3.14, 2.78, 10, 3.14, 2.72, and then 10. Very good. Very good. I'm very happy with this solution. And the final language is going to be Rust, in which we are going to solve this challenge as well. For Rust, we're going to go almost the same way that we went with, I would say, Go, not JavaScript. It's almost the same thing. So we convert our result to a string first. We format it with the string, and then we convert it back to a number. So almost the same thing. And in here we have fn, round to decimal, and this is going to be v1. So what do we pass in here? We have number. That is going to be of type, we know that this is floating point number. So if 64, we have places, this is going to be of integers type. So it's going to be i32. What this function returns is going to be of type floating point number. So I'm going to specify it as f64. So the first thing that we need to do is we need to, again, create a dynamic formatted string kind of thing. And places is going to be variable. So if it is variable, it's going to make it a little bit difficult for us to do that. We could use the format macro that Rust gives us, and we could go almost the same way that we did with Go. So we need to have some kind of place where we specify how many places we want to restrict a specific number by. And Rust, that's actually called a precision. So I'm gonna open up curly braces, which means this is a placeholder for a value. I'm going to pass in the colon. So I'm passing these and I'm explaining what these syntactical things are. This basically means that the formatting options are going to be followed. We're going to pass, what is the formatting option? The formatting option is point, precision, and I'm going to pass in the $sign as well. The $sign point is that we want to select the value from this precision. We don't want to take a look at the actual text the literal precision text. The point means that we are looking at decimal precision that is going to be within this number. And that's it. So this is the formatted template, the formatting template. We pass in the number, and then we need to pass in places. But this places, we have specified that as precision. So places is going to be stored inside of precision. Now, the thing with this is this format macro, it needs an unassigned size as this precision. So we need to cast the type. The type of this is going to be U size. That's a requirement for this precision. We need to terminate this, and I need to store this inside of a variable. I'm going to call it let formatted, and there we go. Let's save that. And the next thing that I'm going to do is just convert this into a number. So this is going to give us our value in the form of a string, but we want it to be a number. So I'm going to say formatted dot parse. On this, we have an association that we need to type annotate. So the type of that is going to be F64. And that's it. And then we want to take a look at the actual value. Therefore, we need to unwrap that. That's what this unwrap method does. And that's it. The first solution is done. The second solution is going to be exactly like the way we went with the other languages. So we have fn round to decimal v2. We pass in the same thing. So let me just copy it up until here and put it right there. Let me add another curly brace. So it's going to be number, and then places is going to be of type I32. First off, we need to create our multiplier. That's going to be, now we have a method that's called pow I. That's going to raise something to the power of something. Now it needs a base. The base of this is 10, as we have talked about that before, but this pow I, it doesn't work on 10. 10 is an integer. Pow I works on a float. So we're going to select this. We're going to say underscore F64, which means, now the way Rust works when it comes to types, most of the times you can say Rust guesses the types, but sometimes in this specific scenario, you need to actually say, okay, 10 is of type F64. Even though it's 10, we just changed the type to floating point number 64. To float, well, I should say float 64. Cool. And then I'm going to pass in places right here. And that's it. So this is going to grab 10 as the base, and it's going to raise it to the power whichever places is. So whatever the number of places is. Then what we did was we shifted this. And how did we do that? We selected the multiplier and we multiplied that by the number. And now this shifted contains the number as a whole, as well as the decimal places, and then point something else. And then that point something else, we need to take a look at that if we need to round that up. So that's going to be rounded. We have shifted. In here, we do have the same method as Python, round, which is going to round this up. And finally, we divide rounded by multiplier. And that's it. And now let me give you the main function. There we go. That's the main function. I'm going to save this and let's go ahead and let's run it. So it's going to be Rust C hyphen tab round to n decimal places. Oh, it compiled the first time. Okay. Let's run the, now we run the file that has the .exe in the name. I'm going to run that. There we go. We got our solution. So it is 3.14, 2.78, 10, and the same thing. Now, as you know, for the second one, I'm going to change this 2.71828 to 2 decimal places just to see that our rounded logic works. Clear Rust, and then run the executable. There we go. It works beautifully. 3.14, 3.14, 2.78, 2.72, and then 10 is 10. Very good. So here is the solution to Rust. Therefore, we're done with this entire challenge. And I think we talked about a lot of things. I really enjoyed this. I really enjoyed creating it, and I enjoyed even more teaching it. I'll see you in challenge 22.